So yeah, as I said, that's a project that came out of the CJ's meeting, the HPC Container Advisory, like 2 months ago, I think, November-ish, where we discussed that we wanted to look into 2 applications, and we picked GROMACS and PyTorch, and to do a little exercise in containerizing those for different sites, and then collecting an idea of what annotations we want to have and how those images need to behave so that we can swap them out. And I will go into the details in this presentation. I called it HPC Container Conformance for lack of a better title, but I think I like the title already. So let's see if someone has a better title, then we can swap it. But I like the title. Anyhow, the presentation is the first iteration on this. So if you have more feedback, if you want to provide input, then feel free to ping me on this. And as I said in the outset, what we want to achieve is we want to create some guidance on how to build images, derive best practices, how those images should behave so that we can swap them out, and also come up with a set of annotations so that sysadmins and users can figure out what the actual image is going to do and what's the content of the image and so on. And also, I think an expectation management is also part of the mix here so that we can create images, and by inspecting the annotations, users can get an idea of and how performant the image is going to run on their system. And what we're not going to do is, we are of course not going to boil the ocean, so not creating like gazillions of images for all the applications and make it work everywhere. We are focusing on GROMACS and PyTorch, and if someone wants to throw in WRF, then maybe WRF, but not more, like 2 or 3, and just exercise or create the example here for those 2 applications. And we are going to focus on OCI images. I think initially, if people like throw Ceros or Singularity build recipes at me, then of course we can also include those. But I think OCI images and created by Docker files is something that people are converging to. So that's the first step at it. And if the Docker file is derived from something else, like a spec environment or an HPCM, CCM recipe, then of course we want also those artifacts so that we can recreate the Docker files after the fact. Okay, so we are going to talk about mainly 2 things. The first one should be really quick. How we expect an image to behave, specifically the entry point and command relationship. So if you don't do anything, what is the expected behavior of the image? And second, what annotations we want to come up with, like what general groups we have and how do we use them and how we create them. And while I researched this, while I worked on this, someone from the biocontainer community picked me a paper that is from 2019, which does something similar, only for the bioinformatics community, which is not so much concerned with targets and optimizing for the host container relationship, but a lot of useful things were there as well, like entry point, reduce the size, create an SBOM, and so on. So it's really worth a read, and it's a couple of pages, so it's a rather nice paper here. Okay, so what is the expected container behavior, at least initially? I think I named it login container and application container. We can discuss the names, I suppose, but the idea is that an image, if you run an image and you are directly running a command, like this Go releaser image, for instance, so that you can basically do an alias with a Docker run command, that's an application container, and it's not dropping you into a bash or in a shell. It's expecting commands and arguments for this application. So and I think we don't want this in HPC because we want MPI run to use the container, and if the container has an entry point that is not a shell, then this is going to not work. So what we actually want, I think, is a container that kind of feels like a login into a login node. Like you run the container and then you're in a shell, and the shell has all the binaries that the container is intended to run. So in this case, like GMX for GROMACS, so that you can do Docker run, you can do Ceros run, you can do MPI run with Singularity, whatever. Like you are expected, the entry point is expected to create a shell or open a shell that has all the binaries and all everything necessary to run a command already in it. And the entry point should be as small as possible, of course. I mean, running a big bash script that does a lot of stuff, or maybe install stuff even, that should not be the case. Even though, let's see what people are using, and then we can discuss this. The upstream GrowMax image, for instance, has a GMX chooser, which is in the path, and which picks the right GMX binary for the user. That, I think that's discouraged, and hopefully we all agree on this, but it's possible, and we should not discard it right away, I think, because people do this. So let's see. And eventually, I think the command maybe just executes the binary and creates a help message or something, but I guess that's up for debate as well. Okay, so that's the first piece. The main part is annotations, and we can discuss the expected behavior piece afterwards, I think. So let's jump right in. So annotations and labels, maybe first a clarification, what's what. The label command in the Docker file creates a label to the container manifest, and the manifest does not, even though the manifest does not have the information, it's in the config, right? So if you create a manifest here, you cannot see it there. You need to go into the config object, the hash, and there the labels are defined for this manifest, right? So the manifest has a configuration, and the configuration includes the labels. So labels are config things. Annotations, on the other hand, are for the OCI specification. They created, within the manifest, they created another key, which is annotations, and these annotations are then just added to a manifest or a manifest list. So instead of having it within the image itself, it's attached to the manifest, so that you don't need to traverse the relationship of a manifest JSON blob and then go to the config JSON blob. The annotations are already in the manifest itself. Curiously, if you have labels defined in your Docker file, they are not automatically attached to the annotations. It's still part of the configuration digest of the manifest itself. But I think it's not unfair to say that the expectation might be that if you have labels in the image, like the actual manifest, and then the corresponding config, you might want to add those into the annotations as well. And when I talked to Valentin about this, he was expecting that Podman or Builder already does this, but it doesn't. But I guess that's maybe to come, so that labels are automatically added here. So to sum up, labels are image config pieces, and annotations are part of the OCI spec for manifests and image indexes. Okay, so what's the base idea? I think in general, the annotations will serve two purposes. So if you have an image, or if you know an image that you want to run, by using the annotations, the end user and sysadmins will get some ideas of what to expect from the image. So what userland is in there, what libraries are in there, what software bill of material actually is in there. And also in which ways the image can be tweaked. So maybe it expects open MPIs in a certain space or in a certain place. Maybe it expects that someone wants to replace the MPI, and those information we can convey to the user and this sysadmin by using annotations. And then once we have those, ideally we can configure hooks or runtime plugins according to the actual annotation in the image. And that's what Ceros already does, right? If you do Ceros -- or Ceros run -- MPI, what this hook -- MPI does, it's just adding an annotation to the configuration of the container, and then the hook is triggered. So Ceros already uses annotations. As I said, if you use -- MPI, it will just add an annotation to the container, and then this will trick or will kick off the hook to tweak the MPI. And what it also provides is that we have a smoke test. So you have a system you want to run your container on. you point to a container, and maybe we can create a little tool that takes the information from the host and checks it with the annotations of the container. And before downloading 30 gigabyte of layers, you can already maybe get the warning of this container won't work because it's a different target, or this container won't work because your hooks are not configured in the right way, something like that, so that we can fail fast and that we can get some information to the user fast and the sysadmin. And the second purpose is, if you don't have an image you want to run, you just want to run GROMACS, for instance, this annotations are, but you know where you want to run it, then those annotations can also inform you to pick the best image for the execution environment. So if you want like GROMACS and your system runs MPitch, then you can look for images with the right annotations and discover the best image for you. And when discussing with Bill, I think it's clear that some are mandatory, which CPU architecture I think is something that we should have, like, in which operating system, I suppose, as well, and kernel maybe, or expected kernel within the container, something like that. And some are optional, and we should have like a couple of mandatory annotations, and without those, you cannot call your container HPC container compliant or conformant. So keep this in mind when we go through the list. Of course, there are some mandatory and some optional ones, and we need somehow to define it. I grouped them into 5 groups, I think, or 4 groups. And I picked the supercontainers.org domain, like the opencontainers.org domain is for the usual annotations, the default ones, and I think we might use this annotation for HPC containers. And I already asked Andrew and Shane, they own the domain, so we can just use those. So what the hardware annotations should convey is, of course, the hardware, and I put in some simple ones. I think the first one maybe is the mandatory one, optimized mode. So is it optimized for an architecture, a generic microarchitecture, or a microarchitecture? So like, is it AMD 64 or x86 64, or is it the V variants, or is it a very like specific microarchitecture for Skylake or for Ice Lake or Zen 2 or whatever? And the others, I think the driver version, I talked to Alberto a couple of times, and I think maybe the driver version we don't need actually. We need the CUDA version, but that's of course up for debate what annotations we have. But I think the general idea is clear. So what is a container inside? What is it comprised of? How is it compiled? And then some information as to figure out whether the container will work or how it will perform. The other one is, of course, MPI stuff. So MPI implementation, is it OpenMPI, MPitch, or is it Thread MPI, and then communication framework and yada, yada. I think there are a lot of other things that we might want to have here. I think an important one is the portability mode one. So if you do MPI replace or libfabric inject, which Alberto discussed at the Canopy workshop, or eventually USIX replace or inject, I think that's would be a hint as to what your hooks, what your runtime needs to provide in order to run this container. So if it's an MPitch with MPI replace and your Saros hook is configured the right way, then off you go. A couple of other things like system annotations, and this is just a basic idea. I think there are a lot of other things that we might want to have here, but I thought like the scripting environment. So if you have what shell is in the container, what Python version is in the container, what glibc is in the container, and so on, and what tools are already included. And maybe this path extra one where you have an empty directory within the container that you can just bind mount over, and which is already in the past, so that you don't need to tweak the environment. You can just bind mount something in there and it will work. And instead of also looking into what the container provides, also maybe looking into what the container expects from the system. So what minimal version of the container ABI you want, what modules you expect to be loaded, and so on. Another important piece, which would be cool, I think, would be like quick start and benchmark guides, how to run this very quickly within one page maybe, how to benchmark it, and how to reproduce and tweak the container build, of course. I think that's also important. Okay, I think we'll just make a quick stop here, or should I just go on? Or maybe let me just go on, and then we can go back to the slides maybe. So I think how to annotate is of course important, but I think that's a multiple stage approach. Of course, the base image should have information about the operating system and what's already installed. Then once someone builds a subsequent image, then we should add more annotations for the subsequent image, basically. And we could also do something after the image is built, and I will show a little example in a couple of slides. So you could also use like Crane, or I think Builder does it as well, where you just point to an image, annotate it, and then push it again. Ideally, the build tools like Spec, Easy Build, and HPCCM already annotate in the right way, and HPCCM already annotates a little bit, but I think Spec would be also a good way of or influencing Todd, like make it Todd's problem. That's what we always do, right? That would be cool if Spec already annotates a container the right way. That would be great. And the benefit, of course, is if we do this within the tools that people use, we don't need the users to actually know about it. It would just be something that is magically done, and it will work. So that would be cool. And that's what I said. Like if we do have images that we do not control, like this collection here from MetaHub would also allow you to just point to an image and then add more annotations, and maybe use different annotations for different images, of course. And so we can play around with annotations before everyone introduces annotations to the actual image itself. And this way would be a workaround until we are in a better place. But I think it will be hard to convince everyone to create labels and agree on labels. So that's a quick fix for that. What we need for this as well, of course, is some system fingerprint, I called it, like RSpec++, where we collect information about the CPU, which would be RSpec, I suppose, the GPU interconnects, and all the stuff that is also related in the container annotation, so that we can make this tool that takes a fingerprint of the host and then looks for annotations in the image, and then combines those and does some magic so that it can figure out whether it works or not. So quick recap, and I rushed through because I want to have some discussion afterwards. So hopefully it was not too fast. But yeah, the container behavior should be, I think, ideally only compiled, of course, for one single set of binaries, only for one target, so not multiple versions of multiple binaries and libraries. It should drop into a shell so that we can replace the runtime with whatever runtime we want to choose. And it's not really dependent on how you execute the container. It's always the same behavior. And the entry point should be make as little runtime tweaks as possible. Annotations, as I said before, the content of the container is what is the first idea of what is described, and also how the container expects to be tweaked, and what it expects from the host should be also another information that is conveyed by annotations. And this will help us, like users and sysadmins, to make sure that for a certain group of images, let's say MPIG version above this version and MPI replacement, we might be able to create configuration and guides so that you can set up your runtime, and with the right annotations, the container will just run, right? Without another submission script or a change in the submission script. We should be able to create this eventually. That would be cool for this year, but let's see how long it takes. Okay, what's next? I think, as I said, I think a tool would be nice to create this fingerprint and also compare the fingerprint to the annotations. I think that's maybe like a little project that I will start. Let's see how it goes. But I think it would be cool if we can say, like, to the user, the performance of this container is going to be on your system is going to be a near bare metal, maybe 90% plus or 95 or whatever your threshold is. And maybe then an orange label that says, okay, the performance is not super great, but it's okay. If you only run it every other month, then maybe you can live with twice runtime because it doesn't really matter. And then maybe a red one that says it won't run at all, or it's such a poor performance that you should not run this container. And then we can do automatic benchmarks, of course. So, and what I want to ideally get out of this as well is like help with the next steps. So what we need to do is collect well-behaving images or collect images at all, so that we have a little group of images that we can try out. And as said, the GROMACS and PyTorch are the applications under consideration here. So if you have GROMACS images publicly available, just shoot them my way, and I can add them, and we can also like talk about what annotations might be added to those images, and we can just play around with this. And ideally, I will do this on, I think, on Parallel Cluster and AWS, because I have some credits. But if people, once we have a couple of images, if people are willing to dedicate some time to run those images like GROMACS and PyTorch and figure out what we need to change in order to make it run, maybe what we can configure so that it automatically picks the right image, or not pick the right image, but picks the right hooks and make the image run seamlessly for the end user, that would be great as well. Yeah, and I said, like this tool for fingerprints and an HPC matcher or whatever you call it, I think that's something that I'm going to do in the next couple of weeks, hopefully. And the goal is for this next step, like hopefully next time at CJ's meeting, I get some time, otherwise maybe only in March, to work towards ISC so that we have some actionable things that we can discuss and talk about, and maybe have some first results on what annotations we are going to propose and push forward throughout the year. So end of May would be great if we can have some more experience with this. Cool. Yeah, that would be it. Thanks a bunch. And if people have questions, then just throw it. I think maybe we can go through it.
I have, so after speaking. So first of all, I like very, very much what you are doing, because this is things, you know, in HPC community should be clear that you don't allow any container in the world. You really want to target for performance, and, you know, performance against portability somehow. I must say that we started a project in this direction a couple of years ago. So maybe as a general comment, I want to invite you to make a presentation to other members of my team. So maybe we can discuss, because some of the topics that you want to cover are actually what we did already. I can point you to this project that we were running, call it MODAC, but you know, this was a European project part of some people that were running on the cloud. They want to have a way to run some containers also on HPC systems. Then again, for the labeling part, so this was the for the entry point part, that I see, yeah, I was discussing, if you, after you remember, I was discussing those conventions. I was calling those conventions, right? How you really want to make a container, what's the entry point. I was also clear that we need to have a single container per each application, not making mixing of stuff. And by the way, I was also thinking, I was also thinking to try to, you know, have some tools that every container has to have, with the testing part. So those kind of things. Again, this very, 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 you know, in line with the general idea. And all the rest, again, it's also, we have a bunch of keywords also there, so forth. So that's great. Really, really, I like your work, what you are doing. So if you can collaborate, please let me know. Otherwise, as I said, my starting point would be if we can set a meeting so that we can reuse what we did and put in maybe some collaboration with you.
Yep, certainly.
Agree, you know.
Oh yeah, let's chat on Slack. And,
yeah. So let me put some info what we did, but I'm done with questions. Sorry, just a point. The thing that I had troubles at that time was what if they have an image and they want to derive for this image to make their own stuff. And I was trying to avoid these kind of situations, because people will screw up easily the container by adding new info and so forth. For instance, they will come.
You're breaking up for me somehow.
Yeah, Alfio disappeared.
Are you still there? maybe not. Yeah, but I guess what Alfio was talking about, like when people add applications or tools, I think that's of course already not a problem, but like if you have a Gromex container, then there are multiple tools within the container, right? And that's true for a lot of other applications. So I guess we need to somehow figure out how to annotate it in the right way so that we know, okay, that's a Gromex container. It has GMX library binary in it and maybe a tool that's used as well. I guess that's something that we need to figure out somehow. Yeah, but I guess that's the details when we are.
Yeah, that's correct. In the meantime, Christian, can you show something? I'm not sure if you're ready for that.
Yeah, I can. Let me.
Just a quick question while Christian is doing that. Christian and I have spoken a bit about the entries here. But I've been doing a lot of work with CWL of late, which is the common workflow language, and it has the ability to create, metadata or schema data within the workflow. So there's a standard for this. So I didn't know whether we should consider using the standard schema entries as a way of putting in metadata for our containers. So they have things like, name, email, or organization, all these things, which they can stamp a workflow with. Maybe I'll post it here, but maybe look at those schema entries and see how they map to what ours are within our metadata, because it is a standard that organizations have stood up for. So those fields might be something that we could leverage.
Yeah, and I mean, I didn't prepare like crazy presentation, but let me check if that works here. So, so I'm logging into password.
And as Alfio said, that we've been both worked for HPE. We had another project that sort of did the same thing, where we were stamping hardware and interconnect metadata into a container. So when we ran across different HPC systems, we could do this pre-check or fail fast. What Christian is presenting here is much more complete a story than what we had originally, but we certainly have codes that we were doing the fail fast and hooks to check for this data before the scheduler even ran, to make sure that that container was compatible with the hardware.
I think I can. I didn't prepare something, so let me just show you the link here, and I think that also already explains it to some degree. So let me put up here my browser. Dip. So that's a basic idea, right? So this image does not have any labels. I think it has one spec label, I think, that's added. But by adding those annotations here in this YAML file, I will, like, MetaHub will serve this image with the right labels and also annotations if you ask for an OCI image. But I think everyone asked for a Docker image. So I will change the configuration object of the manifest and add those labels in so that it feels to the client that the labels were there in the first place. And I think that's a good way of doing a little guesswork first and then iterating towards labels that we all agree on and can work with. So as I said, I talked to Alberto, and if we can all agree on this as an image, as an annotation to define or annotate the image so that everyone knows, okay, it's an MPitch variant in there. And then this annotation maybe that says it wants to replace the MPI within the container, then the Saros hooks can be configured in a way that they already trigger the right hook. So you might have an open MPI hook to do replacement or libfabric injection hook. And depending on the annotations of the image, this will trigger different hooks, and then it will magically run the correct hooks and the container will just work. I mean, that's the goal, right? That the user does not need to change anything, does not need to change his submission script, that he just runs MPI run, Saros run, and then depending on the annotations of the image, it triggers the right configuration and off you go. I mean, that would be my goal at least, and I guess that would be great. Yeah. So I will maybe do a little demo next time, but I thought I won't have much time anyway, so.
So an optional field would also be system name, because a lot of HPC centers have multiple systems which are not the same. So that might be useful for a particular HPC center. Say, you know, this is the big cluster, medium cluster, small cluster, for example. So that when they look at it, they know which one it's going at or is designed to run on.
No, maybe not the size of the cluster, but
no, but the name. I just said small, medium, large for just for as
yeah, but
as an example. But
put that like a Vega, Lumi, or something like that.
Yeah. So whatever name that the data centers call their systems.
Yeah, but I mean, ideally, and of course we can also go down this road for a couple of images, but I guess the initial idea was to create annotations that the center or the system then reacts to, right? So if you would annotate an image that says only run it on Vega, I mean, that's not for the whole community, that's not very useful, right? Because this image won't only work on Vega or is supposed to only work on Vega. I mean, the idea is to, with this project, to create image annotations that everyone can use, right?
Yeah, that makes sense. So it's better to specify the CPU or stuff like that.
Yeah, and agree on a certain set of annotations, and then have like Alberto and some of you guys just run the same image, or at least the same kind of image, maybe with different annotations, and just by using the image with the right annotations, it should work magically work on every system. I mean, that would be great, but it's going to take some more time. But anyways, if we have multiple images here, for instance, there could be one that's only for Vega, and then if you pick the right image, then it will just provide you the Vega one. But I guess ideally we would have images that are very generic and very specific, and the more specific they are, the more annotations they have to inform the user in which ways they are specific.
I fully agree. I got disconnected before. Yeah, I fully agree.
Yeah, you broke up. I think what you wanted to talk about, or you
no, I just left the links on what we were doing on the chat, so you can see briefly what is described, but it's along what you are saying. So again, we can set another meeting for those topics.
Yeah, let's do that. Yeah.
So the idea was actually to make a command that people can run and get the right container for their own system. So the idea is that you have a command, whatever you want to call it, and depending where you are running this command, you will go to a database. You have to have access to the database. So the command will say, okay, I'm running on Lumi, then I have those set instructions, those set of, whatever MPIs, those whatever characteristics. You go to a database and query the database and see what image is matching to run on Lumi. So now the user doesn't need to know, which flag, which specific version or whatever, they just need to have something that is working.
Yeah, totally. And that's the idea of this YAML file that I just showed, right?
Yes.
So that
definitely.
And then we can.
I invite you to check the last page of this PDF document that I was putting there. This was a starting point we were making. So again, no need to go over it now, but this is definitely what we need to. I think this is very, very important, because if you get then these kind of things to share between different centers, then you get some way to leave the user portability, but actually they are not really running the same container, you know. But we assume that via some testings and so on, we assume that those containers, even if they are optimized for different architectures, at the end of the day, they will keep the same result.
Yeah.
So this has to be general enough. I'm thinking about different GPUs, different CPUs, different networks, you know, you name it, right? There are ways to make those matrices as large as you like.
Yeah. Yeah, and also create images that are like, I always pick the GROMACS image as a bad example, but because it has CUDA in it, right? It's like 5 gigabytes of CUDA, even though you run a CPU run. So I think having a very targeted container will also help in creating smaller containers, and maybe even compile CUDA for the exact GPU that you're going to run on. I think will also save some space, right? So that you don't carry the complete CUDA stack, but just the target compute units or compute.
Well, for that, I was trying to make a kind of check what files are used by the executable and try to, you know, reduce the size of the container as much as there is a tool for doing that. And even not can remember now. So there is a way, yeah. So I was trying to squeeze as much as possible and make the container very small.
Yeah.
It works, but again, there you need to, then you go in a real single test, and you are mentioning GROMACS. GROMACS quite it's a framework, right? So they have different kind of simulations they can run. So better don't. But definitely,
right. You can compile GROMACS only with a couple of things.
Dependencies. This is still not clear. GROMACS is fine, but LAMPS, for instance, you can have multiple plugins. It's gonna be a problem, you know. And I'm talking, for instance, has the same kind of dependencies. So it depends how you compile, if what kind of. So likely people they will compile for everything, and then you know, maybe they will never touch some special library.
Yeah.
Okay. Anyway, so fine. That's great. You know, I'm really glad that someone is taking. Yeah. I think we can collaborate for sure.
Cool. And if others, like, just general idea, like if people have like GROMACS images, they have somewhere that I can take a look at and maybe put them in the collections already, and like just examples of how users build GROMACS and PyTorch these days, that would be also great, a great starting point. And they don't need to be pretty, right? I'm not judging anyone sending me a Docker file, and that's
yeah. The idea, my understanding is that AMD will release their own Docker files. AMD. So we will have a way on Infinity Hub. You know, they have a place where they put this stuff and they put on GitHub.
Okay, that's cool. Yeah, that would be great.
So there can be some kind of official stuff there. This was actually Abduram who asked it. So I think they are planning to do that. So. And as far as I know, yet Boomi guys, they are doing also some of those images. So I'm sure tomorrow we will discuss GROMACS. So someone is doing GROMACS, but this is only native. We see how we can make this inside a container.
Yeah, and yeah, if people also volunteer to, once we have a couple of images, to like run those and try those on their systems, that would be great as well. I will work with Alberto and Valentin to create example configurations for Podman and Ceros and maybe others as well, so that we can provide something to work with, right? So that we have a configuration template for how to use those annotations in the real world. I mean, that would be great. But let's see how far we can get. Cool.
Yes, I think that the most important feature is for the users to be able to pull the images that they need when you have them in this database. So I would really like to see a tutorial for researchers when you are ready, Christian.
Yeah, certainly. And yeah, I think this fingerprint tool and this matcher tool somehow that's going to be important pieces. Even though, of course, this matcher logic, I think it's a question of how to encode this matcher logic into this annotations and system fingerprints, right? So the annotations almost gets like to become a rule, like a sub rule or whatever, so that you could say,
Yeah,
this image has a rule within the annotation, and the matcher like takes the rule and evaluates the rule against the fingerprint. I don't know. Like, let's see. I guess there's a PhD hiding in this area somehow, I suppose. But yeah, no, let's see. And I said, I don't want to boil the ocean. Let's just have some examples, and then we can refine once we have the first version. Cool. Yeah, that's it. So if you're interested, I'm on Slack, just ping me, and then we can see how far we can get until SIC.
Abdurrahman, do you think I can